Okay, here's some food for thought on this problem. You're given this piecewise function where you've got x to the x minus 7 for one piece and 6 over x when x is greater than b. The only way that this piecewise function is continuous at x equals b is if when I put b in there, I get the same value as when I put b in there, even though this is the rule we use when x is equal to b. For them to be continuous, this has to be, the limit as we get close to this guy has to be the same value. Okay, so I don't know the expectation of how you're supposed to be able to find that value. One way to do it would be to say f of x equals x to the x minus 7 minus 6 over x, and then find the x-intercepts or roots of that function, perhaps using Newton's method. Other way to do it is to graph each of these functions on a graphing calculator, find the point of intersection that way. On the next page, we'll show that, in fact, there is a value of b that will make this function continuous. And it happens to be about 2.475. If I find the derivative of each piece, here I've shown the work for the first piece. There's the derivative right there. And hopefully what you can see is that if we find g sub 1 prime, or the derivative of this piece, and plug in 2.5 or 2.475, we're going to get a positive number. But if we take the derivative of the second piece, that derivative, no matter what we plug in for x, is going to be negative, because we've got negative 6 over something squared. So that means the derivative from the left, or the slope of the tangent line as we come in from the left of b, will not equal the derivative from the right. And here's the picture. Okay, this is the piece on the left. This is the piece on the right. There's the tangent lines. As we get closer, those are actually the tangent lines, but we could picture the tangent lines getting closer and closer to the secant lines, getting closer and closer to the slopes of these tangent lines, but they're not equal. So the function is not differentiable. And here's Newton's method applied to this function right here. And so there, about x sub 5, the decimal starts repeating. So 2.475, 169, 3216 to several decimal places is the value of b. Okay, there you go. Hope that helped. If you have any questions, post a comment.